So this is the vocabulary that you are going to need in order to kind of process this information and organize your thoughts on this. And I wanted to go ahead and draw another representation of what we just looked at with respect to a symbol and what you'd see on the periodic table. In general, you are going to see an atomic number, which is denoted by the letter Z, which I'm going to write in, let's go with this kind of like burgundy color. Your Z is generally going to be at the top of the screen. Then you're going to have, or at the top of any sort of cell on the periodic table, you're going to have your symbol, which I'm going to denote by XX. Okay. Now below that, what you're going to have is you're going to have the mass number, which is denoted by the letter A. And I'm going to indicate that in green. So your atomic number Z is going to be the number of protons. I'm going to switch back to this color. It's the number of protons, and it gives you your atom's elemental identity. So the number of protons that a specific atom has is going to indicate and clearly lay out the identity of that element. Okay, your mass number A is going to be the sum of your protons and your neutrons. So what that means is you're going to use Z in order to deduce what the number of neutrons are. Okay, this is going close to the mass of the atom, since each proton and neutron weigh approximately 1 atomic mass unit, but it's not an actual mass measurement. Okay, now this last item here, an isotope. This is a piece of terminology that's a little bit of a, it seems like a little bit of a curveball, but the way that I like to think about your terminology with respect to elements is, if you change your number of protons, you've actually changed the element. So if you say, oh, well, I have a single atom of lithium with 3 protons, that's true. And if someone says, oh, well, add another proton to that, do you still have lithium? No, you don't. You have something different. You have something with 4 protons. So the number of protons is fixed. Now, in the event that that is changed, which I know that contradicts what I just said, but in the event that that varies, well, now you're not talking about the same element that you previously were. Okay? You can change number of neutrons, in which case you're no longer talking about the same isotope. Okay, so think about that as lithium. If I use lithium, it can be 3Li7, 3Li8. What's the difference between these? The difference between those two is the mass number. Okay, your mass number is protons plus neutrons. So this specific atom of lithium has 4 neutrons. This one has 5 neutrons. Okay, so that makes them different from one another. And those are isotopes. So they're the same element with a different number of neutrons. So isotopes are going to have the same chemical properties, but slightly different physical properties, such as that atomic mass, or that mass number. So a slight variation here, similar but different from an isotope, is an ion. Ions gain or lose electrons. Now remember, electrons basically have no mass, or effectively have no mass. Now, charge is written as an exponent, both the number and the sign. So that means the magnitude, whether it's a +2 charge or a +1 charge, you want to indicate that. So if we took something like lithium, we had 3 protons, 4 neutrons, and 1 electron. This is a lithium ion that has a, well, let's think about our charges. Plus protons, minus for 1 electron. So Li plus 2. Okay. Now, if you then talk about a different lithium ion, Li, we've got 3 protons, 4 neutrons, and 4 electrons. Now this is an Li that's -1 because it has 3 protons, which are basically canceled out by 3 of our electrons, but then there's an extra electron. So these are two different substances, or sorry, these are 2 substances that have different electronic charges. We have one that is positively charged, one that is negatively charged. The cation is the one which is positively charged because it has lost electrons, or it has fewer electrons than protons, and has a positive charge. The anion, which I'm going to go around here, that's going to be something that gained electrons. So it has more electrons than protons. So what I wanted to do here was I wanted to illustrate the difference between an ion versus an isotope. They're very similar. I like to talk about them with respect to one another because they both deal with the subatomic particles. The ion, you're change number of electrons. And an isotope, you change number of neutrons. So there are 3 subatomic particles: electrons, protons, and neutrons. You do not change number of protons. If you change the number of protons, you're talking about a different element. So you can have an ion and an isotope of the same element. If you change the number of protons, though, you're talking about a different element. So keep that in mind. All right, I hope this is helpful, and we'll keep going with this information. Bye.